I'm Ilya from WSCAD, and I would like to share with you our refactoring experience of involving ODA components to our codebase. WSCAD is a company that creates CAD software for electrical engineers. The main product is a major solution. It has been developing for 30 years. We celebrate its anniversary. And as many software from that time, it was started from reinventing the wheel. The wheel in our case is a graphical engine. What it's supposed to do? First, it draws objects, of course. Lines, circles, hatches, and the whole blocks of different primitives. And it should not only draw object once, but also to redraw them very quickly. For instance, in case of interactive moving operations. Then, the engine transforms these objects for such functionality like zooming or panning. Selection capabilities are also important. When a user clicks somewhere on the drawing, a CAD should identify the object and highlight it. And it should do this job really quick. For this moment, it looks relatively easy, but let's go further. Performance. To be honest, an electrical scheme placed on A4 page is not too big and computationally complicated. But a big electrical cabinet or a plan of the whole building might be a real challenge. Then we need a graphical card acceleration. Import functions. Sometimes users don't want to create a drawing from scratch. They already have prepared document and, let's say, DWG format, and they want to reuse this document. Opposite situation is also valid. When a document is prepared in our CAD, then it might be shared using some exchange formats like DWG or PDF. Historically, we started to use ODA Drawings SDK for import and export. It was helpful for conversion between DWG formats and our internal data model. So, sometime later, a reasonable question appeared. Maybe we can use ODA for drawing also. When you are going to make such a big change in the core of your software, it's vital to understand the main difference between the current approach, that's a custom GDI drawer in our case, and a new one, so ODA. So what were main topics we learned? To get a clean architecture, forget about pixels. Use standard length units like millimeters or inches. And zooming and panning are actually parameters of a viewport. The rest of the application is not obliged to know about them. The scale concept appears only when you project a real-world object, like, I don't know, maybe walls, doors, to a sheet of the paper, so the size of A4. You don't need to spread this scale information across the whole application. These points allow you to design clean layered architecture from the data model layer to the final primitive visualization. The next important observation is that ODA Drawings is a database that keeps primitive. It's not just a canvas. This means that placing a new primitive to the drawing takes more time than drawing it on the GDI canvas. And the application has to track all changes in the data carefully to update the drawing really granularly, because it's really too expensive to redraw the whole picture from scratch every time. And it's much faster to save and then to open the drawing as a DWG file, rather than to recreate it from scratch using internal data model. What you see is what you get is a very important paradigm for CAD systems. And it's not only about equality of the representation on the screen and hard copy, DWG or PDF. The selection also should work accordingly. A primitive is supposed to be highlighted on mouse hover. And ODA actually helps here to keep consistency on all levels mentioned. So the goal of our refactoring here is to use ODA functions as much as possible. Particularly, we made our code much cleaner, drawing out custom selection mechanism, third-party solution to PDF generation, and so on. The next step of simplifying developer's life is to use specific object from a subject area. For instance, instead of calculation geometry for walls, counting intersections, placing doors and windows, it's really much easier to take objects from Architecture SDK. This not allow only to get rid of tons of custom code, but also provides an ability for your software to speak the same language with another CAD system that share the same domain model. What do we have right now as a result? 4 improved functions. First of all, navigation user experience. Zooming and panning are much faster, and they work predictably as for any other commonly used CAD system. Thanks to overlay feature and block support, interactive operation with big objects are smoother now. No freezes, flickering, or any other interesting effects. Applying Architecture SDK allows us to use native built-in elements for our drawing. We provide full DWG compatibility and no more custom geometry computations. As we are using ODA for screen, printing, DWG or PDF, we can be really confident that any user drawing looks the same despite its destination. Also, we got 3 new features that would be hard to implement from scratch. The first good example is an interactive selection highlight. Users see clear now which element is under the cursor. It works fast, reliable, and really free of charge for us. Second good example is a visual aid with dimensions. Users have all the relevant measurements at their fingertips when they're moving some elements, changing its sizes or whatever. And it's not only possible to read the data, but to write it back also using the keyboard. Then, instead of custom import from DWG to our internal data format, that's not only slow but also loses actually data. Now we can combine external files and our content on a single drawing. So, as you see, ODA SDK as the equalizer for CAD development is really helpful to simplify a developer's life, and also it brings the value to the end user. It was Ilya from WSCAD. Thank you for watching.